Hi everybody, welcome back. Lesson 88, page 585, review of proportional and non-proportional relationships. So for the 8th graders, this is day 2. For you 7th graders, day 1. All right, so we want to review that proportional relationships, the graphs are linear and they go through the origin, okay? So you're going to remember that. You're going to also remember that with proportional there are 2 variables, okay? Y equals kx. Okay, an example of that would be something like, if you were babysitting and you charge $10 an hour, $10 is your constant. But these would be variables. In other words, the amount of money that you make is dependent on how many hours you work. Okay, so those are the variables. The constant stays the same as long as you're charging $10, okay? So if I work 3 hours, you'd make $30, right? All right, or it could be the cost of an item, like maybe you're buying a video game and they're 20 bucks a piece. So the constant is 20. If you buy 3 video games times 20, $60 is what you pay. So you have 2 variables, okay? You'll go through the origin if you draw the picture, because if you don't buy any CDs, you don't spend any money. If you don't do any babysitting, you don't make any money, okay? If I'm solving for the constant, I could algebraically divide both sides by x, couldn't I? And so 1k would be y over x. So you can always, in your table, if you have a table of values, okay, if it's proportional, then your y over x will always be the same number. Okay, so that's why we call it a constant. Okay, it could be a different number on a different problem, but in each individual problem, the y over x will always be the same if it's proportional. All right. So now let's take a look at the first example. I'm going to switch over. Hopefully you all can see this, okay, and you've got it in your book. So example 1, state whether each group depicts a proportional relationship and justify your decision. All right, so for choice A, we're not going to cover up the answers. Remember how I always ask you to put your hand horizontally over that? Okay, so for choice A, we have a linear graph if we connect the dots, but it's not going through the origin, so this is not proportional. All right, B, if I connect the dots, it's linear, goes to the origin, there's my correct one. And C, of course, is a curve, so that makes it not. So it says, gives you the answers here. All right, so let's look up at example 2. I'm going to move the document camera up a little bit. Okay, now we're supposed to state, it says here, the following tables reflect or record the effect of dilating on the perimeter and area of a square. So we have a little square here with sides 2, 3, 4, and 5, okay? So you have your chart. So you see your side lengths and your perimeter, because remember with a square, we just multiply by 4. So here, if I did this is x, y, if I did perimeter divide by side, right, y over x, 8 over 2 is 4, 12 over 3 is 4, 16 over 4 is 4, and so on. Now if I do area, so let me preface, this is proportional, right? The constant is 4. Now if I do the area, okay, 2 by 2 is 4, 3 by 3 is 9, 4 by 4 is 16, so on. If I divide the y over the x, 4 over 2 is 2, 9 over 3 is 3. I'm not getting the same number, right? So this one is not proportional. Okay, then we're going to do kind of like I said, we're just doing the basics. So we're going to skip example 3. Some of you can read over it on your own if you want to. But example 4, state whether each equation below indicates a proportional relationship. All right, so here, C equals pi times D. Do you think that's proportional? Well, I think so, because if we divided the D over C, the relationship with proportional. It's always pi is the constant, okay? Here, this would not be, because a over r squared is going to, the denominator would get squared every time, so it's going to be a different value. So there's no way that's proportional. And then this one, if we plugged in 0, 2 times 0 plus 1 would be 1. So we're not getting 0, 0. So it's not proportional, okay? So that is that. Let's see about example 5. I'm going to try to move this up a little bit and see if you guys can see that one. Okay, so this says, which of these problems can be solved with proportional thinking? All right, so first of all, A, if it takes 2 workers 5 hours to complete the job, how long would it take 4 workers to complete the job? Well, if I have more workers, isn't it going to take less time? Yes, so this one's not proportional, because as this increases, this will not increase, it'll decrease, so that's not proportional. All right, for B, the shipping charge is $2 per item plus a $3 flat fee. So it costs $13 to ship 5 items, because we're saying 5 times 2, 10, plus the $3. Okay, so what's the shipping charge on 10 items? So this would not be proportional, because if I plugged in 0, I have to add the $3 flat fee, so it's not going to be proportional. It won't go through the origin. And then lastly, C, each student reads the same number of books. 30 students read a combined total of 150 books. So how many books were read by 60 students? So because it's the same number of books, this is proportional, okay? All right, so let's now look at the practice. Give you a moment. You can turn off the video, do the practice, and then return with me here and we'll go over the answers. Okay, for A, in a proportional relationship, there are how many variables? 2. Okay, one is a constant that stays the same. The graph of the relationship is what shape? A line. And when one variable is 0, what number is the other variable? 0, because it has to go to the origin, 0, 0. All right, B, an equation in the form y equals kx indicates a direct proportion. As x changes by 1, y changes by a constant factor. So which of the equations indicates a direct proportion? B. Okay. Now you may wonder about this one, but this is not a constant, right? Base and height can be different for every problem, so that is not going to work. All right, because you have to have 2 variables. All right, C. See, the equation y equals kx transforms to y over x equals k, which means that the ratio of y to x is constant. So if y over x is 3, then which pair of numbers does not fit the relationship? Okay, so 12 over 4 would be 3, that's good. 18 over 6 would be 3, good. 3 over 9, not 3, that's 1/3. All right, so it's C. All right, for D, which of the following is not an example of proportional relationship? All right, so this choice is C, okay? Distance and time when driving at a constant speed, proportional. Quantity and price when the unit price remains the same, proportional. But hours awake and hours asleep when the number of hours in the day remains the same. Okay, the number of days is the same, but my hours awake and asleep can vary. All right, so it's not going to always be the same amount. All right, and then for E here, which one shows direct proportion? It would be choice A. And then for F, choice A as well. Because you have a constant of 30, right? A little tipped over there, but you guys get it. Okay, so this assignment, everyone, let me write this down for you. Okay, so for your assignment, you're going to have lesson 88. You're doing 1 through, actually 24, sorry. And I believe we are going to skip number 11 and number 18. Now, do your best. Make your best attempt, and you'll see a link to RenWeb is the key. Don't look at it until you're done. You've tried everything. Remember, you learn from trying it on your own. And then when you see the answer, try. Go back, rework it, see if you can figure it out. And then if you still have questions, during our Zoom time, next time, we will go over it, okay? So best wishes, everybody. Have a great time doing your math.